So, pre-calc 9 basics practice. This will be the layout for the next 2 or 3 weeks. And I forgot to do this while I was at work and I haven't been up there. So here we go at home. All right, find the center and radius of the circle if x squared plus 4x plus y squared plus 8y equals negative 17. This is a simple complete the square technique. What we're going to do is we're going to take half of the b term here and here, and you need to be listening. We're going to square it and add it to both sides. All right, so I take half of 4. Remember, b is 4. Take half of that, and I get 2. And I square it, and I get 4. And I add to both sides. All right, so plus 4. Now I have the plus y squared plus 8y. And I'm going to take half 8. 8 over 2 is 4. And 4 to the second is 16. And I add to both sides. All right, so what do we have? We had a negative 17 on the right. We added 4 and we added 16. Let's see what we have. The right-hand side is going to be 3. And x squared plus 4x plus 4 factors is x plus 2 times x plus 2. And y squared plus 8y plus 16 is y plus 4 times y plus 4. And it still equals 3. All right. So what we have is we have an x plus 2 quantity squared plus a y plus 4 quantity squared, because it happened twice, and equals 3. Your center is at -2, -4, because we swap signs when we leave parentheses. And your radius is the square root of 3. So, choice C. What is the domain? We have a composition. We have G composed of f of x. What we're going to do is we're going to take all of f and we're going to put it right there. So we're going to have a square root of a 5 times a 3x minus a 1, and then take away a 4. It's going to give me 15x minus 5 minus 4. It's going to be the square root of 15x minus 9. Unless I made a mistake. No, it looks right. All right, now we talk about the domain. The domain for the square root of anything, the stuff inside has to be greater than or equal to 0. So 15x minus 9 is greater than or equal to 0. This is ridiculous. I don't know why it takes so many times to just get that symbol. You can clearly see that my cursor is on it. Was that try 4? There we go. We're going to add 9. 15x is greater than or equal. I'm just going to do it this way. Greater than or equal to 9. We're going to divide by 5. X is greater than or equal to 9/15. And we're going to reduce 9/15. They're both divisible by 3. And because we have equality, we have to be a bracket. It's going to be 3/5 to infinity. Remember, brackets imply equality. Find all the zeros of this function. That is something that will factor. It takes an x to the second and an x to the second to create an x to the fourth. Factors of 12 are going to be 3 and 4. We need to add to a positive 1 in the middle. I know a couple of y'all are still struggling with basic factoring. I'm struggling with typing. But you'll notice there's a 1x squared in the middle. So negative 3x squared plus 4x squared is positive x squared. This did say find the zeros, so this is equal to a 0. And now we're just going to use the zero product property. X squared minus 3 is a 0. Or x to the second plus a 4 is equal to a 0. All right, so we take this guy and we add 3 to both sides. And that would make x the square plus or minus the square root of 3. So looking for that one means not C, not D, not E. All right, so it's 50-50 now. This one ought to be easy. We subtract 4 from both sides. X squared is a negative 4. So x is going to be plus or minus the square root of a negative is imaginary, 2i. So choice B has everything I'm looking for. 4 is evaluate the cosine of twice pi minus pi over 6. Oh yeah, I can't write on this thing. It's a touch screen, but oddly enough, it will not write. And it crashed too, didn't it? Oh. So I tried using my touch screen. All right, let's try this again. So anyways, on the last one, it was choice B. So when I do 4, I'm going to make 2 pi 360 degrees. I know that pi over 6 is 30 degrees, and you guys do too because you memorize your unit circle. So this becomes the cosine of 330 degrees because 360 minus 30 is 330. So we think about our unit circle. We wish that our touchscreen would write properly. And this is just horrible. Let's clear this page. But anyways, think about your unit circle. I guess I just have to use this. Think about being at 330 degrees. That's going to put you right around here. And think about the ordered pair there. The ordered pair there is that we go right a square root of 3 over 2, and we go down a half. Now, on a unit circle, cosine is x. Cosine is x, and sine is y. So I want the x, which is root 3 over 2. Choice C. Not a hard question. Construct and simplify the difference quotient for f of x equals 2x squared minus 3x plus 5. All right, so everywhere I see an x, I am going to insert x plus h. And I don't have my writing stuff at home, so I can't really write this out well. But first thing I'm going to do is I'm going to find f of x plus h. And that's going to be 2 times an x plus an h squared, so write it twice, minus 3 times an x plus an h, and then plus a 5. So x plus h times x plus h, every time you do it, is x squared plus 2xh plus h to the second. You should have done this about 15 times by now. Some of you have not done it once. Double it, you're going to get 2x to the second plus 4xh plus 2h to the second. minus 3x minus 3h plus 5. Now, the full difference quotient is to take f of x plus h and subtract f of x. It's f of x plus h minus f of x sitting over an h. So sadly, there's more to do. So we're going to have all of this. I'm just going to borrow a line of text here. We take away the original function, which is 2x to the second. And that's all over h. Every bit of it's over h. I need a color. There we go. Now, whatever's inside cancels with whatever's outside. It's a simple process. It's always true. That's all gone. What do we have left? We have a 4xh. We have a 2h to the second. And we have a minus 3h. And it's all over an h. So every term, all four pieces of this fraction have an h. So h over h is a 4x. So I'm looking at either a or d. 2h over h is a 2h. And then I have this minus 3. So it looks to me like that's choice A. All right, for a right triangle, if the sine of theta is 5/7, find the secant of theta. There's a whole bunch of ways of doing this. The easiest way is to probably draw, guess what, a right triangle. Put theta in the corner. Sine is opposite over hypotenuse, 5/7. Secant is the funny guy. Secant is hypotenuse over adjacent. So I'm going to need this side right there. So I'm going to do a little Pythagorean theorem. 5 squared plus some unknown squared is 7 squared. So 7 squared is 49, 5 squared is 25, and 49 minus 25 is 24. So b squared is 24. Don't be the kid who misses this. b is going to be the root of 24, and 24 is 4 times 6, so this is 2 roots of 6. It's horrible. I really wish I had my writing stuff here at home. I should have brought it home with me. 2 roots of 6. Now secant is hypotenuse over adjacent, so it's 7 over 2 root 6. The cleanup process here was to multiply top and bottom by the radical, and we will get 7 roots of 6 over 2 times 6, which is 12. For C. All right, find the solution set for this. So this incorporates some stuff that's been in the last several. The first one is the concept of domain. So remember, for the domain of a fraction of 1 over anything, anything cannot be 0. No, that worked the first time. How about that? So I know that x to the second minus 1 cannot be 0. Of course, not everybody had gotten these down. Am I touching the button? There we go. It's not 0. Now I know that means x cannot be plus or minus 1. So remember, brackets imply equality. So look for parentheses on -1 and 1. Now that makes this a one option question. That forces it to be choice B. Now, the other part of this is that solutions happen in the numerator, not the denominator. So x plus 2 is less than 0. X is less than -2. And we have an issue with this one. In that there is no correct answer present. Because this would use parentheses. Because of symbolism. So there is no correct answer. Doesn't exist. Somebody messed this question up. I didn't create this question. No correct answer. The correct answer would look like this. It would go from -infinity to 2. Yep, here we go with this issue. Union with -1. Oh, hold on, there might be a correct answer here. It would go from -infinity to -1, union with -1 to 1, union with 1 to 2. That's what would be correct, and it's not present. No, that's not it. It would go from -infinity to -2. And that's it. That's what it would do. Nothing more. So I don't know who wrote this question, but they borked it. Determine the equation of the line that is perpendicular to the line that contains the points. I really need to check that. Yeah, anyways. Determine the equation of a line that is perpendicular to the line that contains the points -6, 4, and -2, -5 pass through the point 2, 0. So the first thing you have to do is you're going to have to find your slope. And we're going to do y minus y. It's 4 minus a -5, sitting pretty over -6 minus 2. You guys should know slope by now. That's 9 over -8. Now the perpendicular slope is equal to 8/9. It is the opposite reciprocal, which is weird. -5 minus 4 is -9. And then 2 minus -6 is 8. And here's another question where the author has messed it up. Slope's y minus y over x minus x. No, I made a mistake, didn't I? -6 minus, there it is. Minus a -2. There we go. 4/9. So I need something that has simply 4/9, which means I can't be C, can't be A, and I can't be D. Now I'm going to use good old point slope form, which is y minus y1 equals m times x minus x1. I'm going to take this 0.20 and plug it in. Y minus 0 equals 4/9 of x minus 2. And just do the distributive property. You'll get 4/9 of x. -2 times 4 is -8, so minus 8/9, which means I am choice E. All right, identify all solutions to 2x, 2 cosine squared minus 3 cosine of x plus 1 on the interval from 0 to 360. We were just doing this last week. We're going to factor 2 cosines of x times a cosine of x creates 2 cosines of x squared. Factors of 1 are 1 and 1. Because now I'm looking here. I want to be a minus 3, but yet a product of positive 1, so minus and minus, and check that. This should work. A negative 2 cosine of x minus a cosine of x is negative 3 cosine of x, and I'm equal to a 0. I get to use the zero product property right now. 2 cosines of x minus 1 is a 0, or cosine of x minus a 1 is a 0. So if I take this equation and I solve it for cosine, I'd have that the cosine of x is a half. If I do that same thing down here, I'd have cosine of x is a 1. So now I'm going to think about unit circle. Cosine of x being a half happens at 60 degrees or 300. X being 1 on a unit circle happens at 0 or 360. So that's going to make my choice here, choice B. All right, here's an old school problem. It's the kind of problem they used to ask when I was a kid, way back in the day, 30 plus years ago. So it uses a property of logarithms, and here's the property. A log of ABC is a log of A plus a log of B plus a log of C. Now they tell me there's a 20 here, and I see the numbers 2 and 5. I know that 20 is 2 times 2 times 5. How does that help me? That means that I can write log of 20 I have time for this, is log base A of 2 times 5 times 5, which is log base A of 2 plus log base A of 5 plus log base A of another 5, because I just take these things inside and break it apart. So it's going to be 1.025 plus a 5, which is 1.903, plus another 1.903, and I just add these things together. Well, I don't know why I wrote 2 times 5 times 5. It's 2 times... Man, there we go. I need a 2 there. That should be a 2. Sorry, kids. All right, so that's going to give me 2.05 and 1.93. It's going to be one of these 3s. Should be choice A. All right, number 11 is up next. Solve this thing. We're going to use a property in mathematics. It says if x to the A is equal to x to the B, A equals B. So what I'm going to do is I'm going to rewrite the right-hand side as a base of 2. And that's 2 cubed. Now, 2 cubed is 8. I already had this in the exponential space. So now, since bases are equal, I can set the exponents equal to each other. And I can just do some basic algebra. Not many of you guys got this on your last test. If we add 3x to both sides and take away 1, we'd have this. 4x is 5. This would give me x equals 5/4. Not a hard problem. We have a square root in a domain. We just take the stuff on the inside and we say that it is greater than or equal to 0. And yes, believe it or not, you've been practicing for this. think about your graph here. I know it looks like a parabola. I just need to know these points right here. So I need to factor, maybe. That is horrible. Factors of 4 are 1 and 4. So this gives me that t is -1 and t is -4. Now let me erase this and make this parabola look a little better, more fitting to the problem. It's about the graph, which is something most of y'all don't do on this problem on the last couple of basics quizzes. It's going to happen there to there. And I have equality, so I need brackets. Choice E. All right, 13. Solve that thing. Solve log base 2 of x minus 2 plus log base 2 of x plus 1 equals 2. And we're kind of going to be using the property we used on 10. So I like 10, actually. We are going to condense the logarithm. Addition becomes multiplication. I've taught logarithms for years and years and years, and I know how you guys view them. There we go. We're going to do log is base argument exponent 2 to the second equals all of this stuff inside, which if I FOIL is x squared plus x minus 2. 2 squared is 4. If I take away 4 from both sides, I have minus 6. And this guy factors, that's going to be a plus 3 and a minus 2, because -2 plus 3 is the one in the middle. So my solutions here would be that x is -3 or x is 2. Now, I have another rule that I have to know. For a logarithm with something in it, the stuff inside is bigger than 0. If I put a -3 in here, this log fails here and here. The -3 is extraneous. The only valid answer is choice C. 14, we've got an easy one. The only thing about it is it's going to take me a while because I have to type. That's what stinks. I'm going to take the square root of both sides to fix the square. All right. So x plus 3 is plus or minus 6. So x is going to be -3 plus or minus 6. I don't know why I'm saying -6, though, because I'm just being silly. -3 plus 6 is 3. -3 minus 6 is -9. Easy peasy lemon squeezy. 15 is a factoring problem. We pull an x from both pieces. Then we factor again using a difference of 2 square patterns. I get x is 0, -3, or +3, which would be choice A. Number 16, we're going to isolate the radical. And I'm going to have to switch over to exponential notation to type this thing out. Now, the third root is going to be the 1/3 power. Four minus 2 is 2. The opposite of the 1/3 power is to cube everything. And that causes, on the left-hand side, a complete cancellation, and 2 cubed is 8. We take away 2 from both sides, we get 6, and hey, all that work and x is 1. Nice. Almost done, kids. 17 is going to be a super easy one. One thing difficult about it is that you get fractions. Just do that old distributive property and you'll be in good shape. But some of y'all will probably miss this one. Anyways, if I combine my x's on the left, I have a negative 5x. Looks like plus 2. That equals x plus a 6. X is on one side, numbers on the other. Negative 5x minus x is negative 6x. And 6 minus 2 is 4. Divide out that negative 6, and x is negative 2/3, which is choice A. 18, we've got a quadratic formula problem because it ain't going to factor. I hate typing these out. All right. So it's x equals negative b plus or minus square root b squared minus 4ac. All over 2a. All right, so inside we have a 1 plus a 28. We have 1 plus or minus a root of 29. And it's all over 2. See how hard that was? Choice D. I think this is the last page. It is. Cool. Last 3 problems. 19 is going to use the same property as this guy. Same property. So x to the second must equal 13x minus 12. And what we'll do is we'll one-side it, shift everything left. Now it's equal to 0. We'll factor. Let's see here. That's going to be minus 12 and minus 1, isn't it? So x is 12 or 1. There ain't nothing hard about this thing. Find 2 positive and 2 negative coterminal angles for 260 degrees. Super easy problem. You just add or subtract 360. That's how you find coterminality. So if I do 260 plus 360, 2 plus 3 is 5, 60 plus 6 is 12. I'm thinking about 620. I'm looking for a 620. There's a 620. All right. If I take 620 and add 360, I get 980. So you're gone, you're gone, and you're gone. I could be B or D. If I subtract 360, I'm going to have negative 100. Good, good. And if I subtract 360 again, I'm going to have negative 460. Okay, so this guy failed the test right there, didn't it? It was choice E. Passed all of them. 21. If the arc length of a sector is 8 pi and the radius is 12 centimeters, find the measure of the central angle. So you have a simple formula. It says S is R theta. So the arc length is 8 pi, and it equals R, which is 12, times theta. So I'm just going to divide by 12. 8 pi over 12 is my answer. And I reduce the fraction. That ought to be 2 over 3, right? We'll divisible by 4. So choice D. And there, boys and girls, is your twin. That didn't take me all that long considering I had to type most of it. Would have been about 10 minutes shorter if I'd have been at work.